Hello friends, again welcome in the next lecture of multivariable calculus, and today's our topic is limits along the path. Limits along the path. Okay. So if you try to remember the one variable definition of a limit, when we say that the limit of the function is exist, when we say that limit of the function, limit x tends to a, f of x is equal to L, when we say that, if what we can say that limit x tends to a plus f of x is equal to what? Limit x tends to a minus f of x is equal to L. That means what? If the left hand limit and right hand limit is exist, left hand limit and right hand limit is exist, then we say that and they are equal, then we say that what? Limit of the function is exist. And if they are not equal, that is right limit and left limit is not equal, then what we say that the limit of the function f of xy is not exist. Is it? That means what? Limit of the function is not exist if the left and right limit is not exist. If the left and right limit are exist or not exist, or exist but they are not equal. Okay. So how many cases limit of f of x is not exist? If this limit is exist, if this limit exists, both are equal, then yes, we say that limit is exist. But if it is exist and not equal, then limit of the f of x is not exist. If either one of them is not exist, then also we can say that the limit is not exist. Then what we see in the first one variable function, that is they have two approaches only, left approach and right approach. As x tends to a, x approaches to right or x approaches to left limit and right limit, or x tends to a plus and a minus, it has only two directions in the case of one variable. But if you are taking any point in the xy plane, any point in the xy plane, if you come in the what? Two variable function, here is our AB, suppose. So this should be A, this should be B. In one variable case there is only two approaches, but here this limit can approach from this side, from this side, from this side also. That is, it comes from anywhere. That is, it has infinitely many approaches. It has infinitely many approaches or directions. Any direction it can approach to AB. Okay, xy can approach to AB by infinitely or any direction. It is not that much simple as in case of one variable. In one variable x approaches to a, it thereby only two directions, left and right, but here infinitely many approaches of xy to AB. In the definition, what we see, for every epsilon greater than 0, what is the definition of limit? Limit f of xy, xy tends to AB is equal to L. Then what is the definition? For every epsilon greater than 0, there exists a delta greater than 0 such that deleted neighborhood 0 less than square root of x minus a square plus y minus b square is less than delta, then mod of f of x y minus L is less than epsilon. This definition says only the distance. What it says? Only discuss about the distance, not direction. It is not discuss about the direction. What definition says? Make distance of f of x, y and L arbitrarily small or as much as small by taking sufficiently small delta, that is the distance between the x, y and AB. X, y and AB. Then what we say that in the definition there is not a direction, there is not a discuss a direction, but in this case also if the limit is exist, then all approaches or all xy approaches to AB, then this limit must be equal. This limit must be equal. Okay, that is the path distance along the any path must be equal. That means what? If we get any two path along these two paths, the limit of the function is different, then we directly say that the limit of the function is not exist. Limit of the function is not exist. So very important note you have to write. Note what we can say that if f of xy approaches to L1 as xy tends to AB and along path C1 and if f of xy approaches to L2 as xy tends to AB along path C2, then we say that the limit of f of xy tends is not exist. Okay, so what we are getting, what we are written, suppose f of xy tends to L1 as xy tends to AB along path C1 and f of xy tends to L2 as xy tends to AB along the path C2, then directly we can say that the limit of the f of xy is not exist. But in the second note we can write, but if you get two paths having same limit, you directly cannot say that the limit of the function is exist. Is it? Keep in mind, this is very important. If limit of f of xy along any two path is same, then you cannot say that, directly say that the limit of f of xy is exist. That means what? Two limit have a same path, then we cannot directly say the limit is exist. But yes, definitely we can say if the limit is different, then we directly say that the limit of function is not exist. So this method or limit along the path is useful for showing the limit of the f of xy is not exist. For existence you can go for the next other methods like epsilon delta methods or you can say that the polar method or some other different method, but whenever you have to show that the limit of the function is not exist, then you can go with the help of, or you can show by the limit along the path. Okay, so we will take some example on this. So first example, show that limit xy tends to 0 0, x square minus y square upon x square plus y square does not exist. Does not exist. So what our first example, solution. Solution first, what we have to prove? We have to prove limit xy tends to 0 0, x square minus y square upon x square plus y square does not exist. Okay, so let, or here what we can write here, f of xy is equal to what? X square minus y square upon x square plus y square. So does not exist, so we can show it by limit along the path. Okay, so what we can say, take a limit along the x axis. That is what we can say, that is x axis equation, y is equal to 0. So what we can say, limit xy tends to 0 0. How we write this? F of x0 is limit xy tends to 0 0. So what is here? X square minus y square is what? 0 upon x square plus 0. What should be this? Limit xy tends to 0 0. What we can write? X square upon x square, and this can be written limit xy tends to 0 0. Here x square upon x, it should be 1, and this limit should be 1. So limit of xy, f of x along y is equal to 0 is 1. So we can take again, take a limit of f of xy along a path y is equal, x is equal to 0, that is y axis, along a path y axis or x is equal to 0. Then what we can write? Limit xy tends to 0 0, f of x, what we are, y0, here is 0y, is it? Then what we can get? Limit xy tends to 0 0. What we can write here? 0 minus y square upon 0 plus y square. It should be what? It should be minus 1, is it? Y square get cancelled, and what is the limit? Minus 1. Therefore what we can say, that therefore the limit of f of xy along the path x is equal to 0 and y is equal to 0 are different, along the paths are different. Hence limit of f of xy does not exist, as what we can say, that xy tends to 0 0. Xy tends to 0 0. So limit is not exist, just show the two different limits are exist along the two path. Very simple method. Okay, so you can go for the next example. What is next? What is next? We'll show that the limit. So what we have to show that? Second example, solution. Second solution. So let f of xy is equal to what? Xy upon x square plus y square. Okay. So you can take same any other or different methods, but yes, along the path y is equal to 0, suppose. Okay, so what we can say, limit xy tends to 0 0, f of y is equal to 0 means what? What it is? Along the path y is equal to 0 means x axis, is it? X axis, f of x 0, it should be was limit xy tends to 0 0, is it? Is equal to what? Xy upon 0 upon x square plus 0, it should be what? 0. Take another path along the path yx is equal to 0, that is what we can say, that y-axis, then what should be this? Xy tends to 0 0, f of 0 x 0 y, it should be what? Limit xy tends to 0 0, 0 upon 0 plus y square is equal to what? 0. So two paths in the first example what we are taking, two paths, these two paths already we take, but here both have a same limit, but directly we are not saying that the limit is exist, because what we have to show, that limit is not exist. So go for next path. So many paths are available. Go for next path. Suppose along the path what? Y is equal to x. Along the path y is equal to x. Then what we can write? Limit xx tends to 0 0, f of xx, it should be what? Limit x tends to 0. Xx tends to 0 means x tends to 0. This is our x square plus x square. Is it? It is equal to what? Limit x tends to 0. It should be what? X square upon 2x square, and it should be what? 1 upon 2. You can go for next. Along the path y is equal to minus x. Along the path you can go for next one. So limit x minus x, is it? It tends to 0 0, f of x minus x, what should be this? Again this is same, limit x tends to 0. So this is what? X into y. It is our minus x square upon x square plus x square. It should be what? Limit x tends to 0, minus x square upon 2x square, and now it should be what? It is minus half, and then directly we can say that directly what we can write, therefore the limit along the two paths are different, is it? Along the path different. So what should be write the conclusion? Thus the limit along the path y is equal to x and y is equal to minus x is are 1 upon 2 and minus 1 upon 2 respectively. Hence limit of f of xy is not exist as xy tends to approaches or tends to 0 0. Getting? Very simple. Yes, always these two paths never work. Always these two paths never work. So you can go for so many paths we have. Y is equal to 0, y is x is equal to 0, y is equal to x, y is equal to minus x, y is equal to x square, y is equal to so many paths we have. But there is a one hint to solve. Yes, definitely this problem is clear, completed. But there is a again one more way of solving this method or this problem. So you can say one note, you can write down this note. Whenever we have a function like this, if f of xy or we have f of xy, it is equal to h of xy and upon g of xy, suppose. And here h of xy and g of xy are homogeneous of same degree. They are homogeneous and they are of the same degree. Then take a path y is equal to mx for suitable value of m. Okay, so here what can you go for this? Yes, this is h of xy. What is the degree of this? Homogeneous means each and every term has a same degree, is it? So what is the degree of these two? This here is 1, here is 1, so this is single term. The degree of this term is 2. So it is our h of xy. H of xy is a function. H of xy is a function of 2 degree. Then again here, this is here x square, here x square, same degree. Then this both have a same degree, h of xy, g of xy, or this f of x is homogeneous of degree what? Degree 2. Homogeneous of degree 2. Then you can put here path, you can take path, take limit along path y is equal to mx, where m is parameter. That means what? You can change m changes, you will get the different paths. So what we can say x, so what we can say, limit xy tends to 0 0 f of xy is equal to limit x mx tends to 0 0. What we can write here? X into mx upon x square plus mx square. So what should be this? This should be limit x tends to 0. It is mx square upon x square plus mx square, and it is equal to what? Limit x tends to 0. This x square, mx square, take here x square common out, 1 plus m square. This will get cancelled and we are getting the limit x tends to 0, m upon 1 plus m square. Here x is not there, so value is m upon 1 plus m square. Now what we are getting? Yes, this function has a limit m upon 1 plus m square. But if you change m, you will get the different limits. M is equal to 1, you will get the different limit. M is equal to 1, what you should be limit? 1, here is 1 upon 2. When m is equal to minus 1 upon 2. M is equal to 2, 3, 1, 4, 5, you will get the different limit there. Therefore, if m changes, limit of f of xy changes. Hence Hence what? Limit of f of xy depends on m. Therefore, limit of f of xy as xy tends to 0 0 is not exist. Okay, so you can solve this as by other method also. Okay, so similarly you can solve some other problems also. So what is next problem? Show that limit xy tends to 0 0 xy square upon x square plus y square does not exist. Okay, so again what we can say, I will give you short answer. Third one, it is let f of xy is equal to xy square upon x square plus y raised to 4. So take limit xy tends to 0 0 along a path x is equal to my square. So what we are getting? Limit xy tends to 0 0 f of xy is equal to limit xy tends to, or y, what we can write, my square y. Here is what? My square y square upon, here is my square plus y raised to 4. So what should be this? Limit y tends to 0 my raised to 4 upon m square y square y raised to 4 plus y raised to 4. If you take y raised to 4 common out and you get cancel it, you will get m upon m square plus 1. Thus what we can say that, thus limit depends on m square m. Hence limit of f of xy, limit of f of xy as xy tends to 0 0 is not exist. Simple, you can solve it is very simply. So similarly here is I am giving the hint. So what should, so here is take y common, x minus 1 upon x minus 1 square plus y square. So take 1 minus x is equal to mx, my, n minus x is equal to my, you will get the answer for this. Okay.